Alright folks, this is the last video that I'm going to be making for the Chem 1141 final exam review. This is going to cover a total of 8 questions, questions 18 through 25 on the last semester's exam. Alright, so this first one is a balancing chemical reactions question, and I'm going to show you the way that I like to do this that I previously did, and I'm going to do it again. This is the algebraic method for solving a chemical reaction. What you're going to do is you're going to list out all of the different atoms that are in this equation. We have phosphorus, oxygen, and hydrogen. What you're going to do with those is you're going to set up a balance, or you're going to set up a equation. Okay, so we'll throw letters A, B, and C in front of all of our different species, all of our different molecules. And then we're going to write an equation that represents that. So for A, okay, A is our first molecule, and A is the subscript for phosphorus in that molecule. Is there any phosphorus in the B molecule? No, there's not. Now, we're going to set that equal to our C molecule and the number of phosphorus is there, and that is simply going to be 1. So we're going to write 4A equals C. Okay, now oxygen is next. Oxygen, we're going to write 10A because there are 10 oxygens in molecule A. Now, B, our second molecule, has how many oxygens? Simply 1. So 10A plus B is equal to, well, 4C, the total number of oxygens in our C molecule. After that, we have hydrogen. Hydrogen is going to be our last balance equation, or hydrogen is going to be our third and final equation. And we're going to say 2B is equal to 3C. Now what we need to do with that information is write A, B, and C. We need to figure out the values for A, B, and C. And well, the first thing that we're going to do is, in order to figure these out, we have to define one of them. And we're going to define A as 1. Okay, so we'll plug this in. 4A, or 4, rewrite that as 1, equals C. And if you do that, 4 times 1 equals C, that means C equals 4. Okay, so once we've got this, now we're only left with B. And we could go all the way down to hydrogen. Look at that equation. So 2B is equal to 3 times C, or 3 times 4. Okay, so that means 2B is equal to 12. Divide each side by 2. B, therefore, is equal to 6. We've got a value for A, B, and C, so we can rewrite this as P4O10 reacts with 6 molecules of H2O to produce 4 molecules of H3PO4. So when we do that, what we want to do is kind of bounce back and say, how many phosphoruses are there? Well, based on our newly balanced chemical equation, there are 4 phosphorus on the reactant side and 4 on the product side, because we've got 4 coefficient H3P, there's only 1 there, so 4 times that would be 4 phosphorus. Okay, now oxygen. We have 10 oxygen in our P4O10. We have 6 right here because there are 6 H2O molecules. And then we have 4 oxygen in our H3PO4, but we have 4 of those, so we have a total of 16 oxygen. So I write this as, we're looking for 4 phosphorus, oxygen we're looking for 16, and hydrogen we are looking for, there are 2 in each H2O, so that means there are 12 there. Then on our product side, we're also looking for 12 because we have H3 and we've got 4 of those molecules. So that goes to show that we are balanced. Our question asks, the coefficient of water is what? We figured out that our coefficient for water was A, 6. So that's our right answer for that. Next up, the ions Ca2+ and PO4 3- form a salt with the following formula. Ca2+, PO4 3-. Well, these numbers are just going to switch. The 2 is going to drop down here. But what we have to do is we have to write that PO4 in parentheses because that is a polyatomic ion. So I'll write Ca3, and then put parentheses PO4 2. There we go. Ca3PO42. Answer option C is what we're looking for. That's the best answer option. Of the following, which of the following blank is the largest mass? Okay, so we can look at all of these. This is a little bit of a discrete question. You just have to know these numbers. And I'm going to skip looking at the numbers, and I'm just going to look straight at the units. Femtograms, Fg, that's a very small amount. Milligrams, that's a manageable amount. Picograms, nanograms. Okay, so all of these are smaller than 1 gram. Kilogram, 1 kg is equal to 1,000 grams. So we're above that gram threshold. So E is our best option for that one. And that's so that's our answer. The net ionic equation for the reaction between nitric acid, aqueous nitric acid, and aqueous sodium hydroxide. What I want you to be able to do about this one is recognize that this is an acid plus a base. And you have to know that sodium hydroxide is a strong base. HNO3 plus, and that would be HNO3 plus NaOH. This is asking for the net ionic equation. What this is going to tell you is an acid plus a base, you're going to form a salt plus water. So if we take NaNO3 as one of our products, that is actually aqueous because nitrates are generally going to be soluble. So the product that we're producing here is water. So what we need is, this is just like any other net ionic equation where we are looking for aqueous plus aqueous, but rather than forming a solid, we're forming something that's kind of a non-aqueous product. We're forming a liquid. So we'll put that in parentheses. Okay, and A, C, D, and E don't really show what we're looking for, and they only leave behind aqueous plus aqueous and liquid. The other answer options show a number of different factors, but all that we care about when it comes to a net ionic equation is what actually forms our product. And our product here is water because it is a neutralization reaction. So B is our best answer. Okay, 0.133 mole sample gas in 525 milliliter container has a pressure of 312 torr. The temperature of the gas is blank. Okay, so now what we're given is N equals 0.133 moles. Okay, we're talking about a gas. Most of the time when you're looking at a gas, you should probably look at it as PV equals nRT. Something about this equation, you're going to end up at, or you're possibly going to end up manipulating that equation. So we've got our N defined. Our volume is, I'm just going to write this as liters, so 0.525 liters. Okay, our pressure is 312 torr divided by 760 torr. So 312 divided by 760, and that is 0.411 atmospheres. My R value is going to be my constant 0.08201. And what am I solving for? I'm solving for my temperature, so I need to manipulate this equation so that I divide each side by NR, and I'm left with PV over NR equals T. I've got P, I've got V, I've got N, I've got R. Everything that I need to solve for this equation. So 0.411 times volume 0.525 divided by 0.133 times 0.08201. I'm left with a temperature. You got to remember that your temperature is going to be in Kelvin. So 0.411 times 0.525, close parentheses, divided by 0.133 times 0.08201, close parentheses. And I'm left with 19.78. Now, if you look, there are, wait a minute, just a second. Now, if you look at that, the good thing about this is, or the tricky part about this is, you'll see 19.78, and you'll look at your answer options, and not a single one of those will be even remotely appealing. You got to remember, this is a temperature in Kelvin. The question asks for degrees Celsius. So you have to subtract 273.15 from that. And when you do that, you end up with negative 253.2 degrees Celsius. Okay, now look at our answer options. B is out, C is out, D is out, E is out. But A is pretty darn attractive. We left at negative 253. So that is your correct answer, so you can move on. Which of these metals will be oxidized by the ions of aluminum? So when you look at an activity series chart, you're going to see X goes to X plus electron. So the metal reactivity series, you are going to be given a copy of that. The way that you read it is you're going to look for the placement of an ion, so Y yields Y plus electrons. And the way that this question is worded is asking which metal will be oxidized by ions of aluminum. Okay, so when you look at that activity series chart, essentially what you're presented with is Y plus. Those are your aluminum ions. So what you want to find is a metal with a solid subscript of X above those ions. So if the metal is above the ion, then the metal gives electrons to the ion. So if you mixed zinc, which is very high up on the activity series, meaning it is very easily oxidized, if you mix zinc with Al3 plus ions, you will form Zn plus Al solid. And of course this isn't balanced because you do have to balance that reaction, but zinc is the only metal that is above the aluminum ions. Chromium, iron, magnesium, and nickel are all below. So it is more difficult to oxidize those than to reduce the aluminum. So the best answer there is going to be zinc. Zinc is most easily oxidized. All right. Now this question right here is a Hess's law question. You can know that just right off the bat because you've got reaction A and a reaction B, reaction C. C is what you want to get to. That is your goal. You want to manipulate A and B in order to match up with C because C is delta H equals question mark. You do not know the delta H of that and you are trying to solve it. So A and B are the parts. Those are the steps that you can manipulate to get to C. A reads CaCO3 solid plus CaO, or calcium oxide, producing CO2. I'm sorry, CaCO3 reacts to produce CaCO, or I'm sorry, CaO and CO2. Your delta H is 178.1 kilojoules. Reaction B reads that graphite plus O2 yields CO2, and that reaction is delta H negative 393.5 kilojoules. The enthalpy of this overall reaction is CaCO3 solid yields CaO plus graphite plus O2. Okay, so what you want to do whenever you're confronted with this sort of problem is find your staples, find the things that don't change. And whenever I look at reaction A, what I see is that CaCO3, that is my decomposition. That is the product, or that is the reactant that I'm decomposing in my overall reaction. So when I look at reaction A, I don't want to switch that because I want my reactant here to be my reaction, my overall product. Now, B, my reaction B, on the other hand, what I see there is carbon as a solid in graphite form is a reactant, but it's a product in my overall reaction, in my reaction C. So what I need to do there is take B and flip it. So CO2 yields C, let me write graphite here, plus O2. My delta H for this reaction, since I flipped the reaction, I've got to flip the sign. It's 393.5 kilojoules. It's not a negative number, instead it's positive. So I'm going to scribble B out because I've rewritten B in how I want it to be presented. So now what I need to do is combine my reactants. So CaCO3 plus CO2. Okay? So that's the reactants for A and my newly rewritten B. Those two reactants will combine to form CaO plus CO2. Those are my two reactants from reaction A. They will also produce they will also produce C in the form of graphite plus O2. Okay, so now what I want to do is look for things that are the same in my overall rewritten reaction where I've combined all my reactants and my products. And what I see is that CO2 is both a reactant right here and it's a product. And if it's a reactant and a product, then I don't need to worry about it. It basically did nothing in that reaction. So what I see is that I'm left with CaCO3 producing CaO plus carbon plus O2. Okay, so is everything balanced? I've got one Ca, I've got one carbon on my product side, 3 oxygen on my reactant side, 1 oxygen in CaO, and 2 oxygens in O2, so I'm balanced there. So now what I need to do is I need to combine my delta H's. Delta H 178.1 plus 393.5, 178.1 plus 393.5 combined to give me a delta H that is 571.6 kilojoules. Looking at my answer options, I've got negative 571. That's not it. Don't be fooled. 215 out of the question. 7.01. Nope, that's not interesting. And I'm left with 571 and negative 215. So 571. There we go. D is my best answer option. Okay. My last question that I'm going to be covering is the formula weight of silver chromate, Ag2Cr04. Okay, so I need 2 times the mass of Ag. I'm going to get that from the periodic table. 1 times the mass of Cr, and 4 times the mass of oxygen. Okay, so when I look at the periodic table, what I'm going to see is the mass of oxygen is 15. Oopsies. 0.999. Cr is 51.996. Ag is 107.87. So I'm going to plug all these numbers in to my calculator. I'm going to do parentheses because I love parentheses. Parentheses 2 times 107.87 close parentheses plus 51.996 close parentheses plus 4 times 15.999 close parentheses equals, all told, 331.732. Okay, so 331, A is out, B is out, C is out, E is out. I'm left with answer option D. Alright, well that concludes all the practice problems that I want to go through with y'all. I wish you the best of luck on this final exam. You have the keys for both of the other exams. You have the keys for both forms of the exam. Those questions, they're just scrambled up. If you know how to do this, if you can do very well on all these sorts of questions, I think you're going to do very well on the final exam. Alright, well, have a great day. Bye.